Hello again, as because I got cut off because of the 15 minutes. I just want to give one more example of this so that we make sure that we understand sort of where the jumps in ionization energy are happening. So if we look at aluminum, unlike sodium and magnesium, the jump in ionization energy level occurs between the third ionization energy level and the fourth ionization energy level. And the question, why is this? Okay, well, aluminum has 3 valence electrons, and it also has 3 energy levels. So that first electron that you're removing is in the third energy level. That second electron that you're removing is in the third energy level. And that third electron that you're removing is in the third energy level. Okay? So again, aluminum has 3 valence electrons. But when you remove the fourth energy level, that electron is in the second energy level. You see the huge jump up in energy here. Like almost 8,000, more than 8,000, kilojoules here. So, why is that? Well, this member with 3 valence electrons, so that fourth electron that you remove is in the second energy level. And again, that energy level is closer to the nucleus in distance, so it experiences greater coulombic attractions between the protons and the electrons. And therefore, it's harder to pull away that electron in the second energy level compared to these 3 electrons that are in the third energy level. Okay, so I want to summarize how to answer these periodic trend questions. Okay, so the first thing you should do is locate the elements on the periodic table and find out how many energy levels they have. And just so you know, when we get to this, energy levels is given by the letter N. Okay, now, if they're in the same energy level or the same row on the periodic table, they have the same N, okay, you need to justify your answer using the number of protons and talking about the greater effective nuclear charge, or the ZF, if you're going to abbreviate it, okay? Because again, more protons, greater effective nuclear charge, more pull on those electrons, and that reasoning is always the same, okay? Now, if they're in a different N, and this should say group, not row, I copied and pasted and forgot to change it, so they say group. So if they have a different N, and they're in the same group on the periodic table, okay, this is due to the distance. Okay, because elements that are lower on the periodic table, there's a greater distance between the outermost electrons in the nucleus. And as a result, when the electron is further away, they experience less coulombic attractions between the nucleus and the energy levels, or the protons and the electrons. Okay, so again, just to summarize, okay, when you're talking about elements in the same row, okay, you're going to be talking about greater effective nuclear charge because of there being more protons. And if you're talking about elements in the same group, it has to do with the distance, and atoms that are bigger, okay, the electrons experience less coulombic attractions because they're further away from the protons, so there's less attraction between them. Okay. Also helpful to remember is that the trend for ionization energy and electronegativity is the same. Okay. As you go across, it gets bigger. And as you go down, it gets smaller in size, or smaller in value. And then the trend for atomic radius is the reverse of those. As you go across, it gets smaller, and as you go down, it gets bigger. You will practice this through the questions that I attached in the email and you got in class, and then also Wednesday on the Do Now. Enjoy the rest of your vacation.